What I'd like to do for this lesson is to start by introducing the special right triangles. So if I were to take, if we had a square, okay, I'm just going to draw a square. If we had a square, this doesn't look like a very good square. If we had a square, I know that all of our sides would be equal on this square, and all of our angles would be 90 degrees. Well, if I take that square and then cut it in half diagonally, which is what we've done here, then we have an isosceles triangle. An isosceles triangle being a triangle with two equal sides, okay? So instead of this being 90 degrees, we've now cut it in half, and we've got two angles here of 45 degrees and 45 degrees, okay? And if our side lengths of our original square were 1 and 1 and 1 and 1, to find the hypotenuse of our triangle, the triangle would be the square root of 1 squared plus 1 squared, which would be the square root of 2. Okay, so I'm just going to rewrite that as square root of 2. And so there's our most basic triangle. So now if I look at that triangle and I said, let's find the sine, cosine, and tangent. Let's try and find the trig ratios for those specific angles. In this particular triangle, we've got the angle 45 degrees. So no matter which, oops, class is over. If we are looking at the sine of 45 degrees, I'm going to fill in this row of our table here. The sine of 45 will sine, if this is my reference angle, this would be my opposite, and this would be my hypotenuse, and this would be my adjacent. Now because this triangle is an isosceles, and the 45 is also here, my opposite would still be 1, and my adjacent would still be 1, and my hypotenuse would still be the square root of 2. So I can use either angle because both angles are the same. So the sine of 45 degrees, no matter which angle I use, would be the opposite over the hypotenuse, right? Sine being opposite over hypotenuse, which would be 1 over root 2, which I can leave like that, or we could change that to root 2 over 2 if we rationalize. Okay, cosine adjacent over hypotenuse would be 1 over root 2, which would be root 2 over 2. And then, of course, the tangent would be opposite over adjacent, 1 over 1, or simply 1. Okay? Now, sometimes students don't understand why these numbers come about or where. Now, if we understand trig ratios are simply fractions or reduced fractions for particular triangles. So I'm just going to pop into a new note here. Whoops. I want to add a note. If I can do that. Hold on here. Oh, I've got to go out of here. I'm like, what's going on? Sorry. I'm going to add a note. Now, sometimes students are like, well, why is it 1, 1, and 1? You just made it like that. So let's use some other numbers, okay? Let's use, instead of 1, 1, and 1, let's use, I don't know, 5, 5, and 5. And 5. Okay, I'm going to draw another square. Instead of my side lengths being 1, 1, 1, 1, I'm going to make those side lengths 5, 5, 5, 5. So again, I'm creating a square, and if all of our side lengths are 5, and if we bisect this diagonally, okay, instead of 90 degrees, we've now got 45 degrees and 45 degrees, same thing, and our hypotenuse here would now be the square root of 5 squared plus 5 squared, which would be the square root of 50, 25 plus 25, which if we simplify, that's 25 times 2, which would be 5 root 2. So our new hypotenuse would be 5 root 2. So now let's look at the ratios of sine of 45, cosine of 45, and tan of 45. Okay, so the sine of 45 would still be the opposite over the hypotenuse. This would be my opposite, and this would be our hypotenuse. So we would get 5 over 5 root 2. Well, these two 5s would reduce to equal 1 over 1, right? 5 divided by 5 is 1. So now we've got 1 over root 2 again, which is equal to root 2 over 2. So we get the same thing because, of course, it's a ratio, okay? Our sine ratios are a ratio, and so the very basic, when we reduce it, is root 2 over 2. And the same thing with cosine of 45. Our adjacent over hypotenuse would be 5 over 5 root 2 again, which would equal to root 2 over 2. And our tangent would be our opposite over adjacent, which would be 5 over 5 again, which would equal to 1. Okay, so no matter how you slice it, those are our ratios for sine, cosine, and tan of 45. If we go back to our notes here, there they are. Now we kind of have to either memorize those or we memorize the triangle, and I find it easier to memorize the triangle, but we'll look at that again in a minute. The other kind of triangle I want to look at is this one on the right, okay, the second one, and the way I like to kind of introduce this triangle is I like to say, imagine that we had an equilateral triangle to begin with. And we know an equilateral triangle is the one in which this side length and this side length and this side length are all the same. Well, if this were a 2 and a 2 and a 2, if we cut this triangle in half, this is no longer a 2 here, then we would have 1 and 1. Okay, so I'm just going to look at my left-hand triangle, okay, the triangle on the left, and if we just look at that one, let's just, and what I notice here is I've got the hypotenuse now and the base of the triangle being 1. If I wanted the height of that triangle, I could calculate that height. Okay, my height here, I shouldn't say height because that kind of confuses us with hypotenuse, but this side length would be the square root of 2 squared minus 1 squared, because we've got the hypotenuse already, so we're going to subtract. That's the square root of 4 minus 1, which is the square root of 3. So there's our root 3. Now, in an equilateral triangle, all three of these angles opposite equal sides in an equilateral triangle. If I have an equilateral triangle, then my angles opposite equal sides are also equal. So these, if I take 180 degrees, which I know is the total angles degrees in a triangle, and divide by 3, these are each 60 degrees. So 60, 60, and 60. Okay, so same thing down here. This would be 60. This would have been 60. And now when I cut this guy up top here in half, this is now 30 degrees. So I've got a 30, 60, 90 on my left-hand side, and that's the one I'm going to focus in on now. If I want the sine of 30, 30 is my reference angle. With respect to 30 degrees, I'm just going to put that in blue. Then this would be the opposite, and this would be the adjacent, and this would be the hypotenuse. So the sine of 30, opposite over hypotenuse, would be 1/2. Cosine of 30, adjacent over hypotenuse, would be root 3 over 2. And the tan of 30, the opposite over the adjacent, would be 1 over root 3. And if we look at 60 degrees, if my 60 degrees is my reference angle here, let's just do this in pink. If that's 60 degrees, then this is the opposite of 60, and this number 1 here is the adjacent of 60. Remember, the opposite and adjacent change depending on which reference angle you're using. And so the sine of 60 would be the opposite over the hypotenuse, which would be root 3 over 2. The cosine of 60 would be the adjacent over the hypotenuse, which would be 1 over 2. And the tan would be the opposite over adjacent, which would be root 3 over 1, or just root 3. Okay, so I hope you can kind of see where those triangle ratios come from. So if we look down below, what I do, or what I like to do, is I like to just have the simplest form of these triangles drawn, not with all this gobbledygook. So what I would do is I would draw this triangle, like here. Okay, I'm going to recreate the 45, 45, 90. Okay, so that's 45 and 45. And this side length is 1, 1, and root 2. And I'm going to recreate my 30, 60, 90 triangle. And so I know that this one here is 60, this is 90, and this is 30. and this is 1, 2, and root 3. So I can kind of memorize those two. And so if I want the sine of 60, instead of looking at the table, that doesn't really mean too much to me, I'm just going to hone in on my two triangles. So the sine of 60, I look at where I see 60 degrees here. Here's 60 degrees. The sine of 60, opposite over hypotenuse. So the sine of 60, therefore, is root 3 over 2. Okay? The cosine of 225, well, that's a little harder, isn't it? Because I don't have a 225-degree angle. I've got these 45s, and I've got the 30 and the 60. But let's just think about 225 for a minute here. If I think about 225, that's in my third quadrant. If I zoom in to the third quadrant here, okay, and there's my theta, which is 225 degrees. I'm really looking at a reference angle here of 225 minus 180, which is 45 degrees. So really, the angle that I'm looking at here is right here, 45 degrees. And so thinking about the cast rule, I know that in my third quadrant, tan is the only ratio that is positive, and that's of course because opposite over adjacent is both negative, and negative divided by negative is positive. If I look at recreating this, this would be a 45, and this would be a 45, and here's my 90, 1, 1, and root 2, but this is negative and negative. What I look at here is the cosine of 45 would be negative 1 over root 2. Now, if I just think about my special triangles, I don't have to recreate that and put that triangle inside every time. I can say, well, I know the cast rule tells me that in the fourth quadrant, cosine is going to be negative. So I know my answer is going to be negative, and then I just find the reference angle 45, and the ratio for 45 is 1 over root 2, and I throw a negative sign in front of it. So tan of 330, before I draw a picture, I know my reference angle there would be 30 degrees, okay? My theta ref, right? Our theta ref here was 45 degrees. Our reference angle here is 30 degrees. That comes from 360 minus 330. And so I think about that tan ratio in that fourth quadrant, because I know I'm in the fourth quadrant, C-A-S-T, and in the fourth quadrant, tan is negative. So I know my answer is going to be negative. And the tangent of 30 degrees, my reference angle, is tan of 30. Here's 30. It's the opposite over the adjacent. So 1 over root 3 with a negative. And again, I could always sort of transpose that into my fourth quadrant, putting my 30-degree angle right here as my reference angle, right? And this is 330 degrees. Whoops, 330, not 33. And if this is 30, then this is my right angle. And if I transpose that, this would be 1, 2, and root 3 like that. And this would be my negative 1. So of course, because tan is opposite over adjacent, that is how we come up with our opposite over adjacent. It's a negative 1 over root 3, which makes it a negative 1 over root 3. Okay, so those are our first three here. Let's clip along. Again, 315, I know I'm in the fourth quadrant, okay? What quadrant am I in? So let's just think this through. I know I'm in the fourth quadrant. I know that cosine is negative in the fourth quadrant because I've got that cast rule that tells me so. And my reference angle here is 45 degrees. 360 minus 315 is 45 degrees. And the sine of 45 is 1 over root 2, or root 2 over 2. Okay? And I'm just looking at my triangle, 45, the sine of 45, opposite over the hypotenuse, 1 over root 2. Okay? Or rationalized root 2 over 2. Again, times by root 2 over root 2, which gives me root 2 over 2. Okay, cosine of 150, again, I think to myself, what quadrant am I in? I'm in the second quadrant. Okay, we're in Q2, cast rule, C-A-S-T. So So cosine is going to be negative. I know that right away because sine is the only ratio that's positive. And if I move 150, my reference angle is 30 degrees. So if my reference angle is 30, the cosine of 30, looking at my triangle, 30 degrees, that's the adjacent over the hypotenuse. Okay, the adjacent of 30 is right here, and the hypotenuse is right here, so it's root 3 over 2. Negative root 3 over 2. And the tangent of 120, again, that's the second quadrant, okay? But my reference angle now, if we've gone 120 degrees, our reference angle here would be 60 degrees. Because 180 minus 120 is, of course, 60. And CAST, tan is negative in this quadrant, so I know it's going to be a negative because it's opposite over adjacent. The opposite is positive and the adjacent is negative here. And the tan of 60 degrees being right up here, let's hone in on there. Tan of 60, opposite over adjacent, root 3 over 1. So it's going to be a negative root 3, or root 3 over 1, same thing. And all this brings us to our unit circle. So what we're actually doing here is we're kind of clipping around this thing called a unit circle. Well, why is it a unit circle? If I actually think about many points on a grid, okay, where this comes from is, let's just draw this for a second here. We think about a point here, and a point here, and a point here, and a point here, and some points here. What happens if we do enough points or we create enough triangles, we end up with a circle, okay? Now, of course, I'm not drawing that probably to the best of my ability or accurately, perfectly accurately, but if we keep drawing triangles, what we end up with is many, many points, and all of those points create, of course, a circle. Okay, now, why is it called a unit circle? Because we say that our radius is equal to 1. Now, what the heck does that mean when I think back to these triangles? Well, right now, this triangle has a radius or a hypotenuse of 2, and this one over here has a hypotenuse of root 2. So that's a little bit confusing. Well, let's go back to our note for a second here. And if I look at this first one, or if I look at this one here with the 5, 5, and the 5 root 2, let's just look at that one. We can look at that one, or we could even just look at our basic 1, 1, and root 2. And if I wanted to recreate this hypotenuse to make that equal to 1, how would I do that? Well, I can divide root 2 by root 2 to make that equal to 1. And what I do to one side, I'm just making basically a similar triangle, okay, by shrinking that down. Instead of having a side length of root 2 and 1, I'm dividing 1 by root 2. So 1 divided by root 2, if we were to think of that, it would be 0.707. So a little bit smaller. Now, my side length here is 1. So we've now got a triangle that looks like this, which is 1 over root 2, 1 over root 2, and 1. But if we know this is still 45 degrees and 45 degrees, okay, if we still look at our ratios, our sine ratio is still 1 over root 2 over 1. So sine of 45 is still 1 over root 2 or root 2 over 2. Cosine of 45 is still adjacent over hypotenuse, which is 1 over root 2 or over 1, or 1 over root 2, which is root 2 over 2, okay? And our tan ratio, which was 1 before, okay, is still opposite over adjacent, which is tan of 45 is still 1 over root 2 over 1 over root 2, which is 1. So what this all boils down to is no matter how you draw a 45, 45, 90 degree triangle, these two side lengths have to be the same, and this one here would be 1 to 0.707, or just that much bigger. Okay, there's the only ratios that you can create that 45, 45, 90 degree angle triangle. Okay, so if we go back here to our notes, if we're looking at the unit circle, what we're basically saying is that our radius is all 1, 1, 1. Okay, so with our 45, 45, 90, we've got 1 over root 2, and 1 over root 2. And we had the 30, 60, 90. And so what happens with this one, this was 60, and this is 30, and there's our 90. This was 1, 2, and root 3. But if I want to create this with a hypotenuse of 1, I have to divide everything through by 2. So now I've got a 1, but my ratio is still root 3 over 2, 1 over 2, and 1. Okay, if I said the sine of 60, we're still going to get root 3 over 2 over 1, because the 2 over 2 is equal to 1. So hopefully that's sort of making sense. It's a little complicated until we try it a little bit. If I look at this as sort of a, we call this the unit circle, if I look at just the coordinates here, and if I'm moving around this circle, let's just first of all count out the degrees. This would be 0 degrees, okay? And then if I want to count by 45, this would be the middle. This would be 45 degrees, and this would be 90 degrees. So I'm just counting by 45s. Halfway to 90 would be 45. 0, I could just do 90s first. 0, 90, 180, 270, and back to 360. Okay, and now if we count by 45s, we get 45, 90, 90 plus 45 is 135, 180 plus 45 would be 225, and then it takes us to 270 and 315 up to 360. So I've just counted by 45 degrees. 45 degrees plus another 45 would be 90, plus another 45 would be 135, etc. Now I want to count by 30 degrees. So I would go 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and back to 360. So those are our angles on our unit circle. And if I know that my radius is 1, and that means no matter where I am here, that this hypotenuse for each triangle, for each and every triangle, has to be a length of 1. So therefore, a squared plus b squared would equal 1. And for instance, if I went to go to this first point for 30 degrees, meaning that this is 30 degrees here, okay, I'm just going to get rid of some of that red. If this is 30 degrees, then my opposite side, which would be my y value, and my adjacent side, which would be my x value, and those two squared would have to equal to 1. So if I keep that in mind, if I were just to move over here to the 0 degree mark on my coordinate grid, this would be the point 1, 0. Okay, and if we move up into the 90 degree, this would be the point 0, 1. And these are called the quadrantal angles because they're right on the x-axis or the y-axis. Okay, this is the x-axis, of course, and the y-axis. So when I think about this, if I go all the way to the left to 180, I'm at negative 1, 0. If I go all the way down, I'm at 0, negative 1 for 270. Now I want to think about and transpose my coordinates for my 30-degree angle here. If I think about my 30-degree angle and basically take this triangle here and rotate it on its side, if I rotate that on its side, what I'm getting there is my x coordinate here would be root 3 over 2, and my y coordinate would be 1/2. So this is root 3 over 2 and 1/2. And if I think about my 45-45 triangle, if I take that and I rotate it onto its side here, oops, and I just grabbed some of my circle over here, but that's okay, we can redraw that. Okay. If I take that 45-45, then I know that these coordinates here, just do this in orange, okay, this from here to here would be 1 over root 2 and 1 over root 2, or root 2 over 2 and root 2 over 2, if this is rationalized. Okay, and if we take this guy here again and we turn it on its side and then flip it, okay, so I don't think I can flip that so easily, so what I'll do is let's just redraw it. I'm just going to redraw it so that I've got my 60-degree angle going this way. Okay, we're just recreating it in a different orientation. If this is 60 here, then this is 1/2, and this is root 3 over 2, and this is 1, okay, because that was 1. And this is 30 up here. I'm basically taking this guy here, and we're just recreating that at the 60-degree mark. So if we just grab, say, purple here, okay, then I know that this along the edge here is 1/2 along my x-axis, and my y-axis would be root 3 over 2. So here this would be 1 over 2 and root 3 over 2. So I've just created the first quadrant of my unit circle, and if I know that, these are the only values that we have to memorize. And the reason we want to memorize these ones is because these are the exact value ratios. Okay, if I were to find like the sine of 29 degrees or 34 degrees, it's not an exact value, so we won't have to memorize them. These are the ones that create exact values, and this is why we like these ones. So if I were to transpose these into the second quadrant, okay, if I notice here, by the way, all of my ratios are positive because x and y is both positive in this quadrant. If we move to our second quadrant, and if I want to look at, say, the 60-degree angle, which transposes to the 120, if we reflect that over the y-axis, then our coordinates there would be negative 1/2 and root 3 over 2, because x is negative in the second quadrant. So to move to this point, I've moved negative 1/2, I've moved left 1/2, and we've moved up root 3 over 2. With the 45-45 angle, which is transposes to the 135, we get a negative root 2 over 2 and a root 2 over 2. And with our 30 degree, which transposes to 150, right? 150 is our theta. That would be our standard position angle. Our reference angle would be 30. This angle here would be, the coordinates here would be negative root 3 over 2 and 1/2. So those are our new coordinates. And now that I know those ones, I can easily transpose those down below. So the negative root 3 over 2 is the same because x is still negative, but y is also negative. And the negative root 2 over 2 is the same because x is still negative, but now y is also negative. And my negative 1/2 and negative root 3 over 2. And of course down here, same thing, except x is positive, so it's 1 over 2 and negative root 3 over 2, root 2 over 2 and negative root 2 over 2, and root 3 over 2 and negative 1/2. So those are all of our coordinates for our coordinate grid for the exact value ratios that we need to memorize. So we kind of can memorize these, or we can memorize the triangles. Either one will work, okay? And this positive negative just basically says what is positive and what is negative here, and we know that's the CAS rule, okay? Sine is positive, cosine and tan are negative, okay? Positive here would be tan, negative would be sine and cosine, and positive here would be cosine, and sine and tan would be negative. So we can either refer back to our unit circle, or we can memorize our triangles. For the quadrantals, so quadrantal angles are the ones that land on the x and y axis, okay? These are angles on the x or y axis. So for example, these are the quadrantal angles right up top here, but I'm just going to draw them, okay? That's 0 degrees, 90 degrees, 180 degrees, or 270 degrees, or 360 degrees. And the 360 is equal to the 0 degrees, okay? Because we end up back at the same spot. So if I look at my unit circle here, this is the coordinates 1, 0. This is 0, 1. This is negative 1, 0, and 0, negative 1. And so when we look at our ratios, okay, back to these for just a moment, if we look at the sine ratio, the sine of 30, for example, is y over hypotenuse. So y over 1 ends up being just y. If sine is the opposite over the hypotenuse, and our hypotenuse is simply 1, and our opposite is our y coordinate, then therefore sine of theta is y, okay? And if cosine of theta is the adjacent over the hypotenuse, and again, if our hypotenuse is 1 and our adjacent is x, okay, x is our adjacent over hypotenuse, therefore we can simplify that and say that x is the cosine of theta. Keeping that in mind, if x is cosine and y is sine of theta, then that transfers to my quadrantal angles as well. So let's look at all of these quadrantals. This is x and y, and x and y, and x and y, and x and y. So if y is sine and x is cosine, let's just look at the sine of theta, and sine I'm looking for y. Cosine is x. Okay, and we'll look at tangent again in a second. So the y value at 0 degrees, the y value at 0, I look on my unit circle at 0 degrees, my y coordinate is 0. My y value at 90 degrees is 1. My y value at 180 degrees is 0, and my y value at 270 is negative 1. The cosine would be my x value. My x value at 0 would be 1. My x value at 90 would be 0. My x value at 180 would be negative 1, and my x value at 270 would be 0. Now tangent, I know that tangent is opposite over adjacent, so let's look back at this triangle. If the tangent is the opposite over the adjacent, this would be the opposite, and this would be my adjacent. So that's the y over the x, okay? If tan of theta is opposite over the adjacent, that's the y over the x values. So I know that y over x is equal to tan theta. So I'm going to look at my y value divided by my x value. At 0 degrees, that's 0 divided by 1, which is 0. At 90 degrees, that's 1 divided by 0, which is undefined. at 180 degrees, that's 0 divided by negative 1, which is 0. And at 270 degrees rather, that's negative 1 over 0, which is undefined. So now it says determine the exact value of cosine of 135. If I want, there's two ways to do this. I can think about my unit circle, or I can do my special triangles, which I've kind of shown a little bit. But now that I have a unit circle of 135, I want to think, what quadrant am I in? I'm in my second quadrant. Okay. Theta is 135. My reference angle is 45 degrees. I can either think of, I know that cosine, my cast rule, sine is the only one that's positive in that quadrant, so therefore I know my ratio is going to be negative. I know that the cosine of 45 is root 2 over 2, or 1 over root 2. And I'm thinking of my triangles, okay? 1, 1, and root 2. So cosine adjacent over hypotenuse, I can think of it like that. Or, now that I have my unit circle, I go to 135 on my unit circle. The cosine is the x, so that's negative root 2 over 2. And I've got that just like that. Sine of 240, I could look at my unit circle, 240 degrees. Sine is y, that's negative root 3 over 2. Cotan of 180, well, let's just do tan of 180 to start with. Tan of 180. Okay, this one here, again, tan is y over x. So if I look at my unit circle, y over x, negative 1 over 0. Tan of 180 would be negative 1 over 0, which would be undefined, but cotan would be 0 over negative 1, which would just be 0. Tan of 120, I'm just going to look on my unit circle, 120 degrees. Tan is y over x, so root 3 over 2 divided by negative 1/2. And when I just think of this as fractions, root 3 divided by 2 times negative 2 over 1, those 2's cancel, and we get a negative root 3. The shortcut there is to recognize that these two denominators will cancel each other. So we get negative root 3 over 1, or just negative root 3. Okay, secant of 45. So secant, that is the secondary ratio that goes along with cosine, because remember there's one co in every pair. So I'm first going to find cosine of 45 degrees, and the cosine of 45 I know is adjacent over hypotenuse, or my x coordinate, which is root 2 over 2. So if cosine is root 2 over 2, then secant would be 2 over root 2, which would be 2 root 2 over 2, or just root 2. Okay? And that also came from cos of 45 unrationalized would be 1 over root 2. And if you just simply take the reciprocal of that, you get root 2, or root 2 over 1. Okay, cotan of 330, the ratio for cotan would be the reciprocal of the tan of 330. So the tan of 330, I'm going to look, the tan is y over x, 330 degrees, so it's going to be negative 1/2 over root 3 over 2, okay, negative 1/2 divided by root 3 over 2, okay, and these two little guys here will cancel. And the tan is negative 1 over root 3, so cotan will be negative root 3, or negative root 3 over 1. Okay, so let's look at the last thing here. The last example here says solve for theta. These are all to be done without the calculator. The first 3 lessons in this unit are really to be made for understanding, and no calculators would be used. So if this first equation, we're looking at now an equation, sine of theta is 1/2. So what that's saying is, what is theta? Sine of what angle is 1/2? So what I want to do is I want to think first of all about my cast rule, and I want to say, where is sine positive? Okay, sine, I know cast rule, Sine is positive either in the first or the second quadrant. I'm going to draw two little triangles there, two little sort of reference angles. And so where is sine 1/2? Or in other words, where is y equal to 1/2? Or what ratio is 1/2? And I know if I look at my triangle with the 1, 2, and the root 3, the sine, this would be 30 degrees, this would be 60, and of course this is 90. The one with the sine of 30, sine of 1/2, opposite over hypotenuse would be 30 degrees. Its sine of 30 is 1/2. But now I know that I've got actually two triangles. This would be 30 degrees, this would be 30 degrees, and my actual angle theta would be from my initial arm to my terminal arm. Say, what quadrant am I in? Okay, so let's just go through this one more time. We say, what quadrant? I'm in quadrants 1 and 2, right? Where is sine positive? Okay, where is sine positive using the cast rule? Okay, we're in quadrants 1 and 2. I draw a little picture, and in quadrant 1, okay, theta is equal to 30 degrees, and in quadrant 2, theta is 180 minus 30 degrees. So theta is 30 degrees or 150 degrees. Okay, those are my two angles that would give me a sine of that angle that would be 1/2. Okay, and if I look on my unit circle, okay, I see that there's a y coordinate of 1/2 right here at 150 degrees or at 30 degrees. Okay, let's look at the next example, and I kind of skirted through this, but this just means that theta is between 0 and 360, so it's one rotation around the circle, and it's saying what are the answers that would give me a sine of 1/2. Cos of theta is negative root 3/2. Now, let's just do this as if it were one complete rotation around the circle to start with, okay? If I say, where is cosine negative? So first thing I want to do is say, where's cosine negative? Cosine is negative. Thinking about that cast rule, where am I in terms of a negative cast rule, negative cosine? Cosine is negative in quadrants 2 and 3. So we know we are in quadrants 2 or 3. What's our reference angle? What angle gives us a cosine of root 3/2? Well, if I look at this triangle just drawn right here, this is my adjacent, right? This would be adjacent. So cosine's adjacent over hypotenuse. So this is our adjacent, and this is our hypotenuse. So root 3/2 being our cosine, our reference angle would be 30 degrees again. But now we are in the second and the third quadrant. So theta would be there and here. So theta would be 180 minus 30 and 180 plus 30. So 150 degrees and 210 degrees. Now, because this said that would be the answer if it was from 0 to 360, but our answer if theta was between 0 degrees and 180 degrees would simply be 150 degrees. That would mean we're only going around half the circle, okay? That would mean we're only going to be in this quadrant, the second quadrant right here, from 0 to 180. We would ignore that third quadrant. Okay, let's look at the last two examples. The next one, so before I find theta, I need to isolate. So I'm going to move over my 1, and we get root 2 sine theta, whoops, equals, what am I doing? Root 2 sine theta is -1, and divide both sides by root 2, and so sine of theta is -1 over root 2. So the negative sign tells me what quadrant am I in. So where is sine negative? Sine is negative, if I think about that cast rule, down here in quadrants 3 and quadrant 4. So I know I'm in quadrant 3 or 4. my reference angle of 1 over, what would my reference angle be that would give me an opposite over hypotenuse of 1 over root 2? Well, of course, that's our 45, 45 triangle. That's 1, 1, and root 2. And so our theta ref, our reference angle is 45 degrees. And if we go from here to here, or from here to here, to our terminal arm, theta would be 180 plus 45 degrees, or 360 minus 45 degrees. So 225 degrees and 315 degrees. Those would be our two answers. Okay, and our very last question, sine of theta would be root 3 over 2. And of course, root 3 over 2, that comes from our 30, 60, 90 triangle. And again, I say what quadrants would I be in? Okay, this is 1, 2, and root 3. And this is the 30 and the 60. Sine is opposite over hypotenuse, so my reference angle would be 60 degrees if that's the opposite, and this is the hypotenuse. And so where is sine positive? I'm either in the first or the second quadrant. So Q1, this is 60 degrees, and Q2, this is 60 degrees, and root 3 over 2. Then I know that theta is 60 degrees in my first quadrant, or 180 minus 60. So theta would be 60, or 120 degrees. So hopefully this makes sense, and for the assignment, I would aspire to do all of the questions if you want to fully understand. Okay, good luck, and if you have any questions or concerns, please do not